In this lecture, we will be discussing set operators and views. Set operators can be used to combine the results of two or more queries, or select statements. There are four set operators in SQL Server. We have union and union all, both of which can be used to combine the results of the queries. Union suppresses duplicate values between the queries, and union all does not. Intersect returns only the rows that are in both queries, and except returns the rows in the first that are not in the second. So if we look at a Venn diagram, we can see the differences between our set operators. Union and union all are both circles. Intersect is just where they overlap, and except is the first but not the second. When we use set operators, the queries must have the same number of columns selected. The data types in the columns we select must be in the same order in each query. So for instance, if the first column is an int in the first query, in the second query it should also be an int. If they don't match, we will have some errors when we try to run our set operator queries. Our queries don't have to use the same tables and set operators. So let's do some examples with union and union all. I've got SQL Server already connected. So let's write a query that shows us all of the countries that our customers and suppliers and employees are in, the countries and cities. So in this example, we're actually going to use 3 queries, one for each of these. So we're going to write those queries first and then put them together with set operators. First, what I'm going to do is to select the city and country that our customers are in. So select from customers, C, C.city, C.country. Pretty simple query. We have 92 rows there. Then let's get the ones from suppliers. So select from suppliers as S, S.city, S.country. And if I run that, I get 29. So I'm just going to add some comments with the record counts. 92 records, 29 records, and then let's get them from employees as well. From employees, E, E.city, E.country, and this is 22. So if we run these all together, we get 3 different sets of data here. But we can combine these sets with set operators. So let's do union first. So I would just put the word union between them, and when I run the first 2 together, now instead of getting 2 separate sets, I just get 1 set of data. And now I have 94 records. 92 plus 29 is not 94. What happens with union is that anytime there are duplicates, they get thrown out. So our data gets sorted and deduplicated with union. So if I want to join in the results of the last set as well, I put union between that query and the first 2 again. Move this down. And now when I run these all 3 together, I get 1 set of results. So I get 103 records, 103 distinct city and country combinations between customers, suppliers, and employees. Now, I'm going to show you the difference with union all. So if I do union all in here, for both of them. I had 103 for union. With union all, I get 143, and nothing is sorted. So what happens here is it takes the results from the first one, adds the results from the second, adds the results from the third. If I want to sort these, I can put an order by at the bottom of the last query. Order by city, country. And then they're sorted, and we can see where our duplicates are occurring here. So that's the difference between union and union all. Union gets rid of our duplicate values. Union all shows us all the records from all of the queries. One other thing to note is that our aliases that we use in our order by come from the first query listed. Also the aliases we get as our headers. So if I do as CNTRY for country for short, I want to order by that. Even though that isn't in all of my queries, when I run this, that's the header I get. So if I ever want to alias all of my items in my set operator queries, I want to do it in the first query. Okay, so intersect and except. So intersect returns the distinct rows that are in both sets of data, and except returns the ones in the first query that are not in the second. So let's do a different example for this. Let's do customers that ordered both chai and tofu. If I want to know what customers are ordering both of those products, I can do that. So I'm going to start by writing a query for one of them. Select from. So here we're going to need a lot of tables. We're going to need customers, orders, order details, and products to understand which customers have ordered chai tea. So that's the first one we're going to write. So from customers, C, and we join customers to orders, orders O. Those join on the customer ID. So customer tables customer ID equals the order tables customer ID. I'm going to put my star so my IntelliSense will keep working. Next, we need to join to order details. So join order details, OD, and that joins to orders on the order IDs. Orders order ID equals order details order ID. And then we need to go to products to get the names. So we join to products, P, and products joins to order details on the product IDs. On order details product ID, equals the product's product ID. Now I need my where clause to identify chai as the product, where p.productName equals chai. And I want to limit my query only to the customer name. So I see the customers. So c.company name as customer name. So here are my customers who ordered chai, 38 customers. And if I want to know what customers ordered tofu, that is our same query, except for tofu. So if I run this, we see we have 23 customers who ordered tofu. I'm just going to play with my spacing here so that we can fit this all on the screen. So if I want to know which customers ordered both, I want to put intersect between these queries. And then when I run them together, I can see that I get 7 customers who ordered both of those products. Now, if I want to know which customers ordered one product but not the other, I can use an except set operator. So let's say I want, from that list, the customers who ordered chai but did not order tofu. So same 2 base queries here. I'm just going to use the except operator between them. So all the people who have chai, except for the ones that ordered tofu. So when I run that, I see we have 24. 24 people ordered chai but not tofu. I want to talk about some common issues with set operator queries before we move on. So the first problem that happens a lot, I'm going to grab this query. So this would give us all of the records from customers and suppliers, all the cities and countries. First issue would be selecting columns in the wrong order. I'm going to do a union here. So what I should get when I union these is 94 distinct records. However, if in this one I wasn't paying attention and I first selected the country and then the city, now I have 99 because some of these records have city listed first and then country, and some of them have country and then city. However, notice we still have the city and country headers. Again, that's because it takes our headers from our first query in our set operator query. So that is a logic problem in our query. Query still runs. Okay. So I'm going to fix that. Let's just leave the country. Another issue, having mismatched number of columns between our 2 queries. So in my first one I have 2 columns, and my second I have 1. This gives me an error. It says all queries combined with union, intersect, or except operator must have equal number of expressions in their target list. So expressions means columns, target list means select clauses. So this does produce an error. And the next issue is having mismatched data types between the columns. So let's select the countries, and just for fun, let's select the customer ID and the supplier ID. Now this won't actually reduce any of the number of columns, or sorry, number of rows returned. So we could use union all here because the unique ones, we're not going to get any unique records removed because customer ID is never going to match supplier ID. If we look at customer ID, it's a char field, so it's characters, and supplier ID is an int. So if we weren't paying attention, we might think that this would work. But when we run this, we get an error that says conversion failed when converting the value ALFKI to a data type int. So what happens through our data type precedence is that integers are a higher precedence in SQL. It's not really important to know, I just want to explain what's going on here. So when SQL Server sees that we have a char data type and an int data type, it's going to try to convert those to the higher data type precedence, which is the int. But we can't convert this value, so this is our first value in customer ID, to an int, so it fails. So that's what happens when we get mismatched data types. Those are our common problems when we use set operators. So now we are going to move on to views. Views are permanent objects in our database. They exist there. They will show up in SQL Server, and I'll show you where we can see them. However, they don't actually store data. So it looks like a table, but it's not really a table. It is a stored query in essence. We use views for a number of reasons. Frequently, we do this to reduce complexity in the query. So if we have a really complicated query that we want an end user to run, say in a report, or be able to build their own reports on, we could put it inside of a view, and then the end user can use the view instead. They don't have to worry about how all of the joins work between our tables. It's handled within our view. Another reason we might use it is because it's a query we write very frequently. So we are constantly joining the same things together. We can put that inside of a view so that we don't have to spend our time joining all the time. Another option or reason we might use views is to restrict users' access to sensitive data. So let's say we have employee information in our database, and in our employees table we have their name and their job title and their extension and their email address, similarly to what we have in the Northwind Traders database. But we also have their social security number and their home address, which are some pieces that we probably don't want everybody in the company to see. We could write a view that shows only that directory information for employees, so their name, their phone number, their work phone, their email address, their job title, and let pretty much everybody in the company have access to that data. However, then they don't see the social security number and the employee's home address and home phone, which is good because only a few people in the organization should be able to see those pieces of information. So views can be really helpful for allowing people to access some data from a table, but not everything. Views are really simple to create. We start by writing a query. We can add column aliases if we want. And then at the top of that query, we put 4 words: create view, some name for that view, and the word as. And that creates our view. The only caveat with this is we cannot have an order by clause in the query that we use to create our view. So let's go ahead and create a view. Let's say we want a view that shows the suppliers and the products they have all together in one query. So suppliers and their products. View of suppliers and their products. So we're going to start by just writing the query. Select star, we'll come back and clean that up, from suppliers, S, join or inner join, because those are interchangeable, inner join products, P, on s.product or s.supplier ID equals p.supplier ID. So the supplier's supplier ID equals the product's supplier ID. So let's include the supplier ID from the suppliers table, the company name, and we're going to give this an alias of supplier name. Let's include the product ID and the product name. So if I run this, I see all that information. Let's also include the category ID from products so that we can use that later on. Pretty simple query. If we want to create this as a view, we make sure our query works first. We test it. We make sure all of our joins are correct. We make sure that the data that's showing up is what we expect. Then we come here and we say create view. Have to give it a name. So something that describes what this information is. So I'm going to call it supplier products. As. And then I run it, and instead of getting data back, it says command completed successfully, which means it created my view. Great. Where is it? How do I find it? So I go into my database, and usually we go into tables, but under tables you'll see we have a folder called views. If we go into that views folder, I now see I have a view called supplier products. And if I click on it, I can see columns in here, just like I would under a table. And I can see what the data types are, and I can see if null values are allowed or not. Now, if we want to use this view, we just select it. At this point, we pretend it's a table and we use it just like we would a table. So select star from supplier products. So my view can be the only thing in the from clause, or I could join to other tables as well. One thing I want to point out real quick, if you noticed when I put the select statement here, I have red text here. This says create view must be the only statement in the batch. That means that SQL Server will only create the view if we run this alone. So I couldn't run both of these queries on this query window and get it to create my view. I would just have to highlight and run this, and then it would work. So I could just select from there, or since I included that category ID, I could also join to the categories table and list the category name. So from supplier products, so I'm going to call this SP for short, join categories, C. And now up here I used category ID from products. So if we were to look at our ER diagram, we'd know that category ID in products links to the category ID in categories. And since that's what the category ID in supplier products is from, that's how I can join those two. So supplier products joins to categories on the supplier products product ID, category ID equals the categories category ID. And so now I can say sp dot, say the supplier name, sp dot product ID, sp dot product name, and C.category name. And I can sort here too, so order by supplier name, product name. So pretty much anything I can do with a table, I can do with a view, especially in a select statement. So there's really no difference in using a view versus using a table in a select statement. So if for some reason we decide that we've written our view and it doesn't really meet our needs, we need to change what's in it, we can change the definition of our view using an alter view statement. So it basically defines a new query for our view. So I'm going to take my create view statement and I'm going to move it down here. And let's say we determined that we also need some more information about our suppliers. So let's include the supplier contact name, the supplier contact title, and the supplier phone number. So we want to be able to easily get in contact with the suppliers about these products. So I'm going to test my query again, make sure that the data is correct, make sure that the order of my columns is correct, and then instead of create view, I'm just going to say alter view. And again, this is unhappy because it wants it to be the only statement on the screen. So I can fix that by highlighting my query and running it. So now if I look at my views, this is the original information. If I right click, I can say refresh. And then it will show me my updated columns in my view. So I can again do a select star from supplier products. And it shows me my updated view. So if for some reason I decide that I really don't like that view anymore and I want to remove it from my database, I use a drop view command to do that. So remove the view, drop view, name of the view. So supplier products. Drop view supplier products. I run that. It says command completed successfully. Now if I update my views folder, I have no views. It's gone. So I could recreate it if I wanted, or if I really didn't want it anymore, it's gone. Right. That is the end of this lecture. Please follow up by watching the lecture on using views in Access.